Good afternoon, good evening, everybody. Welcome to Percona Live 2021. My name is Ronald Bradford, and today I'm going to be giving you a little bit of a help about Amazon's QLDB, specifically for MySQL or PostgreSQL users. No prior knowledge is required for QLDB. The only need is for you to have an AWS account, and you will be able to run through some of the examples that I'll be presenting. So what is QLDB? What are its features and capabilities? Why would you consider this? Are important questions that I'm going to be going through in this presentation. I'm also going to focus on a comparison between MySQL syntax and QLDB syntax. However, if you understand PostgreSQL, the syntax is practically identical. I'm also going to go through an example migration and some observations that I had in a POC that we performed. There are quite a lot of slides in this presentation, and during the short talk, I'll be skipping over those, but they'll be available in the slide deck at the end of the presentation. So what is QLDB? I'm going to read Amazon's specific description. Amazon's Quantum Ledger Database is a fully managed ledger database that provides a transparent, immutable, and cryptographical verifiable transaction log owned by a central trusted authority. Amazon QLDB can use to track each and every application data change and maintains a complete and verifiable history of changes over time. That's quite a lot to pack in as your introduction to this. I'm just going to point out a few things. This is a ledger database, and immutable and cryptographically verifiable and a central trusted authority are three pillars that are important in this conversation. So if you're unfamiliar with what a ledger is, I'm going to talk about the history of very quickly of a general ledger or financial transactions, where basically you have a spreadsheet and the list of the rows and the columns would line up to the beginning and opening closing balance that you would have for your bank account, which is a third-party verification. In this particular case, it's right. If you're missing a single row of categorization or you're missing a correct calculation of a column, then you will have a mismatch. And therefore, the spreadsheet itself will not line up. It's not verifiable with your actual external resource. Or if, for example, the details of your ledger do not line up with your third-party source, in this particular case, a bank account, your ledger is not accurate. So if we take this idea and apply it to a database, some of QLDB's features are it's immutable. In the prior example, if you're using a spreadsheet, you can change the numbers. You can also fudge the numbers so that they do actually sum up. So that's not immutable. Verifiable means that for every data change, there is a cryptographical hash, and that is used in the application of the subsequent changes. So there is no way for you to actually intentionally manipulate the data to come up with the actual result. Some of the features of QLDB which help us in our traditional database worlds is it supports SQL notation. However, it has a much smarter data type, which I'll be discussing, and it's a structure that doesn't require DDL changes, for example, so you can change it per SQL statement. So why would you consider a ledger database? There are several limitations of people who have tried to implement these inside relational databases. Generally, there's no standard approach, and the most practical solution is to use a trigger-based system where you track the changes of data that's inserted, updated, or deleted. This comes with inherent problems such as ensuring that the schema is correct, any schema changes are applied, and then it's also possible to trick that altering or disable it and not guarantee that there is a verifiable record of the changes that you've made in the database. All of these things lead to considering a ledger approach. So I mentioned QLDB contains SQL notation. AWS has a concept of party QL. It's an open source implementation that you can go to, and it provides a subset of that functionality for QLDB, supporting a traditional SQL syntax. However, it also supports much more features, including like a fully nested data set example I will show you. I will point out, though, that in the versioning, it is quite early in its descriptors, 0.1.5 at GitHub. When I talked earlier about data types, we don't think of tables and columns exactly. While there are table structures, columns themselves actually belong to a concept called Amazon Ion, which is a rich hierarchical format of data and it is a superset of JSON. So if you understand JSON, you can start there. Some of its features are its capabilities of being able to access the information internally. It's not something I'm going to go through much in this presentation. So what are some of the observations about QLDB? The first thing is it's serverless. So an observation is it's rather slow. If you're looking for a high performance, then this may be something that you'll need to investigate more. The biggest hurdle was there are no unique constraints, and I'm going to go through that in a lot of detail. There is the benefit of less strict syntax checking, but that is also a pro and a con. While you can lift and shift an existing application, a strong normalized form application, that limits the capabilities that QLDB has, and I'll provide an example of that. But if you want to have auditing, if you want a verification that your data is accurate and you can verify the changes and you can look at all that history, this is exactly what QLDB does, and I haven't found any issues with doing that. So let's go through a step-by-step syntax comparison of the statements that you're used to with SQL. We'll start off with creating the schema. Within QLDB, this is known as a ledger, and you'll create that with the Amazon CLI or with the user interface. So if you have an AWS account, you can get one of those for free. This is all you need to do to create an effective ledger to get started. During these examples, I'm going to provide a syntax between what you do within inside QLDB and a comparison syntax within MySQL using a Docker container. So here we have a ledger called demo and a schema called demo. So when we're creating a table in QLDB, you just have to refer to the table itself. You don't have to refer to any internal structures of that table as you would in MySQL. In this example, you can see that I am providing a number of columns and data types. I'll also show here that their case-sensitive tables are not supported. And there is a QLDB shell. This is a compatible MySQL client type shell. It does have some quirks and limitations. This is a great example where, for this statement, you can't use a semicolon. As you can see here, if you try to create a table that is the same name but a different case, that actually results in an error in QLDB, but not with inside MySQL. Creating index is not unsimilar. You can create an index in MySQL. If you wish to use the create index command, you have to give that index a name. If you use it with inside alter table, you don't have to give it a name. You can also create multiple indexes. So in this particular example, while the previously in MySQL, I created a primary key, you would create this as an index inside the ledger. There is an information schema. It appears to only be one table, and this table is called user tables. So you can get some meta information about the tables you've created. It is case sensitive, as I've noted here, unlike MySQL, where you have some flexibility in using the term information schema. Inserting is quite straightforward. You just insert your information. But this is where it differs in that the value clause is a JSON object. And QLDB does support multiple inserts. You can insert multiple rows at the same time. And as you can see here, inside my MySQL example, I have traditional columns for an address. But within QLDB, I can define that as its own object with attributes itself. So these are nested values. So in QLDB, we just have a primary key, a name, and an address specifically. Likewise, the select is quite straightforward. You can just select the data and you can retrieve the information that you're looking for. Very similar to what you have inside MySQL. However, I will go through some of the specific QLDB select syntax in the next section. There are some built-in features of SQL and some limitations if you're familiar with writing applications inside MySQL. Inner joins are currently only supported. There are some capabilities for subqueries. I've also listed here some of the a limited list of the functions that are available from PartyQL. And so far, what I found is it's a little difficult to analyze and monitor your queries and the statistics that you have around the database. So we've done insert, we've done select. Update is again quite straightforward. You can just update the information and select that from the database. What I do show here is though that you can actually update the row that you're accessing in the table, and then you can add an extra column within that update. This is sort of the schema-free approach, where when you created the table, there was no definition. And so now we actually have a new column for this particular row that we have updated, and that particular column may or may not exist in other rows within the table in question. If you want to do a delete, again, it's quite straightforward. If you're using the QLDB client, which is the easiest way to sort of navigate around, the best way to know that when a delete is not performing anything, there are no rows returned. I haven't actually built an in-depth application here with QLDB. I've been using primarily the QLDB shell, and then later some Python code to show you how to load the data. So there may be additional information that you can collect regarding the result set and the number of rows applied. So I did mention earlier that there are no unique constraints. And this is a real shortcoming if you are coming from a traditional relational database environment. In this example, you can see that I'm inserting 2 rows with the same primary key. In MySQL, obviously this is rejected because there is a unique constraint on that column. But in QLDB, this is a valid insert statement. So what you see is when you select from the table, you'll actually see 2 rows again. So this is a difference between what you can see in QLDB and what you can have in MySQL. There are transactions. The syntax is slightly different. It's start, abort, and commit, a little bit shorter than our start transaction and rollback capabilities. One interesting thing is that QLDB has a locked-in timeout. And if you're working with inside the shell and you don't cut and paste your commands sufficiently, the query will actually time out. As you can see here, the query is aborted. The timeout is at 30 seconds, and that does not seem to be configurable. So in a application, obviously you need to work inside that. Using a client program like now, you have the delays of user interactions. There is a drop table, and also within QLDB, you can undrop a table, which is a capability that does not exist inside relational databases. As you can see here, when using the information schema, you can see that the table is actually set to an inactive state. And so by identifying the table's internal identifier, you can actually undrop that table. This is another way of that immutability that we were talking about. Every operation that you perform is logged and verified. So there's no way to sort of trick the system into something that may have existed and no longer exists right now. There is some additional extensions. The from command is a way to access those. I've got an example here where I'm going to go through this in a little more detail, where some additional columns were created within the structure itself, and the from statement can either set or insert or remove those attributes within the nested data. So this is also a way in which you can actually manipulate data within a actual object or within an array of objects inside that object, for example. I'm going to go through this example a little bit later, but this was just an example of the syntax. So very quickly, we're under the gun here for our short presentation. You can see that most of the commands that you're familiar with, there is a direct correlation with QLDB's SQL notation. The biggest differences are the create, the transaction changes, the capability of undropping a table, but also this concept of from, which is quite an interesting way to handle the nested data that you're working with. So that's the SQL syntax. Let's look at the specific QLDB auditing capabilities that are in place. There are a few of them. Initially, you would just select the data from a table. I've shown you this before. We can see a row of data of the table. You can see the information that we've created. You can also look at the committed view, the single committed view of the table at this point in time. So as you can see on the right-hand side, we have the data in question, which actually is referenced as a data object inside this underscore QL committed table name. But you can see additional information now that QLDB is holding, including the metadata, dates and times of when things are happening, and underlying block address and hashes. This is the cryptographical verification of the data that you have created. What builds on this view is if you can, you need to use the by syntax within inside SQL to obtain QLDB's internal identifier for every individual row. Now, this is where you may first in your applications have to think about naming conventions for your columns. This is known as ID, but you may have ID in your tables, or you may have a different identifier. I've tried to make it different here just to sort of like point it out. But one of the complications in my example here also was I created the column for the primary key as PKID intentionally so that you could see that. So just be aware here as you start to do nestings in terms of looking at primary keys and the keyword ID. So now that you've grabbed an internal identifier, you can use a history function of the table, and you can optionally specify a period of time. And now you can retrieve the rows, which is the exact representation of what you saw earlier in the QL committed view, but now for each individual change that has been made. So in here, we have a sequence. And so you can actually refer to the data and a version, and you can refer to these data so that you can actually look at the changes over time. And I'm going to go through a very simple example, and I'm going to show you how we can leverage and benefit from that. You can do, for examples, counts. There are mins and maxes. However, I found when here I wanted to look at like the min and max of the date timestamps, I actually had an error. So this is an example where the functions that you look at are a little bit different, and you need to work out how to do type conversion this way to actually use the syntax command that you would be most familiar with inside SQL. Within every commit, there is a transaction. Earlier, when I did a transaction and I rushed through that screen very quickly with the limited time we have, the QLDB shell actually showed you a transaction ID. You can actually use that transaction ID to actually select information specifically. So you have the data and then you have the metadata. In this particular case, you can see I'm looking at a transaction ID specifically, which would return the version of data that was manipulated. And as you can see, TX time, transaction time, is a way where that information is always recordable, something that you don't necessarily need to keep track of in your application moving forward. Here's an interesting example as part of actually creating these slides. It was a happy accident, but this is an example of the loose syntax checking and the loss that you have within a relational database. If a user, for example, refers to the wrong column, then that's going to fail a level of testing that you'll have in place. Inside QLDB, you do not have those constraints. So here I'm updating a row in the table, but I'm updating the column city and state, which is what you would see in the traditional MySQL environment, but we've now made this a nested data type. So there is actually no value city for this individual user. So as I mentioned, this was a nested data type known as address, and now we have a new columns. So now we have two situations where we will need the application didn't stop us from performing this work. So extra validation and testing is going to be needed to make sure that your actual application is actually conforming to any type of structure that you would want in your data. And so here you may have to want to, for example, traditionally you would update those values to null. Null is a data type that is supported. But this is an example where that from syntax comes in. So we can actually remove those original columns that we updated from this particular row and return to the nested data type that we have in place. What happens, however, is that the history will reflect everything that you do, good or bad. So in this particular example, you can see where I'm doing a join, you can see the history has changed from having a city and a state province within the address data type. Now there are additional values, and then those values are set to null before they're subsequently removed. So this level of immutability, which is recording every single transaction that you have, is a way to show that if you want to make a change, then there is always an audit trail. There's no way to say to the system, I just want to undo something that was accidentally rolled out incorrectly by the application. So in summary, the audit capabilities refer to, you have your traditional select statement, but so you can look at the underlying individual committed view of that individual row in that table at that point in time, which contains some metadata and the underlying hash and block data that's being used. I'm not going to go into detail in this presentation. about how you can download and reference that and perform a cryptographical verification of your rows. The select by syntax enables you to get this internal ID that QLDB has for every row and every object. And the history function, as I call it, as it uses round brackets, is a way to drill down into the history of rows within a given time period. So I want to give you a few observations of some of the complexities I went through, and very quickly wrapping up some work in the POC that I work with. Syntax checking doesn't exist. So you can create a column that's not valid, and the SQL statement will work without providing an error. There is no implied type conversion. This is a common problem in MySQL, where applications will wrap quotes around a field, and MySQL will accept that. QLDB, that does not work. Another issue I ran into in loading and retrieving data, deleting data and loading data, was the maximum number of documents that you can modify is 40. That does not seem to be a configurable option. As I mentioned about quotes, the other thing is that you have single quotes and double quotes. So in the shell, for example, you can refer to a column value in double quotes, but it doesn't actually retrieve the value in question. Aliasing is an interesting problem where the error, if you don't know what you're looking for, you may think like, okay, why isn't this not actually working? This is a great example where rows is actually a reserved word. There is quite a list of reserved words. You don't have the capabilities in MySQL to backquote a object reference here. So there are a number of observations. I'm not going to go through these right now for the benefits of time, but they were just things that I came across, and hopefully when you do some examples, this will save you some pain. So I looked at a POC, and we took our existing applications, and these are some of the criteria that I looked for to identify something to work on. We wanted a system or a subsystem. We wanted something that really had an auditing capability and not rows that were just sort of like, a write once type log. And then we had to look into how we're going to migrate this data, what's involved in the application, what sort of feature gaps we would have in place, and do we want to continue with this evaluation? So luckily, we actually came across an environment in one of our systems, which was actually an audit. There is a primary table. There is a sort of non-referenced audit table, which has an implied data table name and ID, and which contains metadata about the change. And then there were individual tables that held the data changes for inserts, updates, and deletes per table. So it's a kind of pseudo relationship here, where there, between the activity, there is a 0 to 1 relationship between individual tables. There were additional tables and intersection tables, but for the purposes of creating this POC, I just used this one table as an example. So there is just some syntax here. This code is available on the gist that is available in the link, and I'll publish it at the end of the presentation in the comments. But you can very quickly go through, create the data inside MySQL, extract that data through MySQL, which I'm going to talk about right now, and import that data into QLDB. Some of the things, again, you would need to look at the gist table structures. I'm not going to go through it here in this short time. One of the so these are some of the things that we did for the benefit of QLDB. The audit table, which was keeping every record, had an identifier who was making that change. By moving that column into the actual table itself, we eliminated the need to keep a record of that. And the actual entire audit table could be removed. The who made the change is now being propagated. The when the change is built into QLDB's transaction time. And what was changed, why was it changed, whether it was an insert, an update, or a delete. There is no direct relationship between an enum that was defined here, but you can use the version number to determine what an individual row state was within the history. Version 0 means it was inserted. When there is no data object, then that row has actually been deleted, and everything in between is an update. So the benefit here is that we actually removed, for one table that had 4 additional tables, we've actually eliminated all 4 tables, and we're left with just one single table. We're also able to collapse several columns. I showed in my earlier example an address where we moved that from multiple columns, and there were actual multiple addresses with duplicated columns now into one single rich data type. And then not shown here is that when we had child tables, by actually adding that as an attribute to the table inside QLDB, you get all the benefits of auditing for free. So this is a more complicated example that hopefully I can provide another presentation on at a later time. We did some mock-up in Python code. There is a library called PyQLDB. However, it's not compatible with QLDB shell, so virtual environments are necessary. I found is when I was testing this, you lose some of the functionality, particularly truncate table. So if you go through the gist, you'll see I have several revisions of my initial code just to show I created it, and then I had to comment things out. What I did find is that using MySQL's shell in MySQL 8, even though our data was in 5.7, produced the exact syntax I wanted of JSON rows to place into QLDB. So in the gist, you will find the examples of that. Where this POC ultimately hit a hurdle, the first hurdle was the lack of ensuring duplicate data. The second was we can't actually load our existing data. So we have an archival history of information, but we can't leverage the columns that QLDB have and, for example, remove those from the table structure and then have that history data in place. So this was actually kind of like the stop of this POC, because we now have to tackle, if we want to create a new system, we have to keep a legacy system of that historical data, or we have to have different ways to query the auditing history over time if everything was migrated into QLDB. I didn't perform any load testing in this example. There is some additional optimizations that the documentation refers to. I'll be honest, I didn't get to this particular level. There is a QLDB lab. AWS has a number of those, and there is actually a section about load and performance testing. However, conveniently, that code is actually marked as to do, and it's not actually in the presentation itself. So there is some future architecture. One of the benefits of streams inside AWS, you can stream your data now out of RDS and Aurora and other sources, which will put that into a Kinesis stream. You can do the same thing with inside QLDB. And this was an example where we might look at how do we take the QLDB as the source of truth and then replicate that data into MySQL, for example, for historical application access or for other types of capabilities. So that functionality is there. So in wrapping up very quickly, I apologize I ran through these slides. The deck does have a lot more slides that I didn't show. The immutability and the verifiable cryptographical work is exactly what you want if you want an audit. So QLDB, is perfect for that. Lifting and shifting an application is more complicated, either in the application syntax or the lack of ability of using some of the functionality that you have in place. The unique constraints was really a blocker for us, and I don't really have a solution around that. And QLDB actually has to be the source of truth. So those things are things to consider in terms of evaluation. It was an interesting product. I am going to look into other capabilities and options to work with it. However, it may be more of a greenfield new application benefit that we want to work with. So I want to thank Percona for running this Percona Live, as they have done in many years with the conferences that in the community. I wanted to finish up a couple of minutes early, so if I have any questions, I will be able to go through those in the chat. So thank you all for attending. I appreciate your time.